Okay, so today's lesson is proving angle relationships. This is the last lesson we're actually going to do as part of 3A, like the first part of the chapter. So tomorrow there'll actually be practice tests, and then we'll have a test on Thursday. As you know, I don't like surprises on tests, so the test will be very predictable. We'll do the practice test tomorrow, which will show you exactly what's on the test and show you what you need to know, and all of that stuff. Today's lesson is very similar to yesterday's where we did the proofs, but we're just bringing in some more like reasons, postulates, and definitions, and these are more specific to angle relationships. A lot of these concepts you have seen before already this year and in years prior, so it's just putting them into a proof format. So yeah, the first one, this postulate, remember the numbers aren't important, that just refers to whatever textbook it was taken out of. But protractor postulate means that if you line up an angle on a protractor like this, you can measure that angle, and that's all that means. Then we have angle addition postulate. This is like the big idea for the lesson, and all angle addition postulate means is this side of the angle plus this side of the angle equals the measure of the whole thing. So the way we'll often see this written is measure of angle ABD, so like the yellow part, plus measure of angle DBC, the green part, equals measure of the angle, the entire thing, ABC. So this is the yellow part plus the green part equals the whole thing. Okay, then down here there is some new theorems. Again, some of these ideas you've seen before, especially vertical angle theorem. I had put a bubble around this the first time we saw it because it comes up a lot, especially in proofs. If two angles are vertical, then they are congruent. And what that looks like, so just to remind you, if you have two intersecting lines, vertical angles are opposite each other. So if this is angle 1 and this is angle 2, these two angles are opposite, so therefore they are equal in measure, they are congruent. So angle 1 equals angle 2. Okay, complement theorem. Complementary angles equal 90 degrees, and that's what this has to do with. If two angles form a right angle, then they are complementary. So if you have a situation like this, where you have a 90-degree angle, and two angles come together to form that 90-degree angle, then angle 1 plus angle 2 equals 90 degrees. Supplement theorem, same idea, but remember supplementary means that the angles add to 180 degrees. If two angles form a linear pair, then they are supplementary. What a linear pair looks like is a straight line with two adjacent angles. So let's call this angle 3 and 4. These two angles form a linear pair because they come together to make that straight line. And we can say angle 3 plus angle 4 equals 180 degrees. Okay, then these two right here, these are new, congruent complements theorem. In this, what it means is if 1 and 5 are complementary, and then 5 and 6 are complementary, then you can say that 1 equals 6. So the way I would write this out would be, okay, angle 4 plus angle 5 equals 90 degrees. And then angle 6 and 5, angle 6 plus angle 5 equals 90 degrees. Therefore, angle 4 is equal to angle 6. That's congruent complements theorem. So if you have two angles that are complementary to the same thing, then they are equal. How does that work if you need like an example? So let's say angle 5 was like 60 degrees, and you're told that angle 4 is complementary with that. 4 would have to be 30 degrees. And then you were told that 6 was complementary to 5. It would also have to be 30 degrees. So therefore 4 and 6 are equal. Okay, and then congruent supplements theorem, same idea but with 180 degrees. So let's say 1 and 2 are supplementary, so angle 1 plus angle 2 equals 180. And then 3 and 2, angle 3 plus angle 2 equals 180. Therefore, angle 1 is equal to angle 3. Okay, so then if, for example, this angle is 150 degrees, this angle is supplementary to it, it would have to be 30 degrees, and if this angle is supplementary to it, it would have to be 30 degrees. So therefore, angle 1 equals angle 3. Okay, there's one more that comes up in the proofs on the homework that I'm going to add. Linear pair postulate. If two angles form a linear pair, then they are supplementary. This one and this one are essentially the same thing, just again, depending on the source, sometimes they call it something different. If you know the vocabulary, then you should be good no matter what. Okay. Next. Okay. This box right here, it's a lot of like, honestly, it's just common sense. It's just like really spelling it out. It's all about perpendicular lines. So what we're going to do in this box is draw a set of perpendicular lines. And perpendicular lines come together to form a right angle. So with that, perpendicular lines intersect to form 4 right angles. So with this box, then all of these angles would then be 90 degrees. All right angles are congruent. Makes sense. Perpendicular lines form congruent adjacent angles. Congruent adjacent angles. Got it. If two angles are congruent and supplementary, then each is a right angle. So if two angles are congruent and supplementary. So if these two angles add to 180 degrees and they are congruent, then they would both be 90 degree angles. And then this one right here, if two congruent angles form a linear pair, then each is a right angle. So got a linear pair here. They're both congruent, so it would look like this. And you have two 90 degree angles. Okay, then this is just a reminder, reflexive, symmetric, and transitive properties also apply to congruent angles. So reflexive property is angle A equals angle A, just like we saw in the last lesson, just it equals itself. Symmetric would be, okay, if angle A equals angle B, then angle B equals angle A. Got it? Then transitive property is, okay, if angle A equals angle B and angle B equals angle C, then angle A equals angle C. Okay, for the next couple examples, we're going to do number 1, but we're going to skip 2 and 3 for the sake of our brains. me zoom in a little bit because it's small. Okay, so this one you saw on your last test. It just comes up a lot, especially in testing as well. One thing they'll want you to do is identify the vertical angles and solve for a variable. So here we have vertical angles right here, and we're going to set those equal and solve for the variable. So y plus 23 equals 63. And then to solve for x right here, we have a linear pair. So this plus this will equal 180, and that's how I'm going to set it up. 2x minus 17 plus 63 equals 180. And then I'll solve for x. It's 46. And x equals 67. Okay, next. In the next portion, we're just going to look at different situations and determine the theorem or postulate that would allow us to come to whatever conclusion they give us. So for number 4, it shows angle 1 and 2. Those are vertical angles, and the conclusion is that they're equal or congruent. So the reason why those are equal is vertical angle theorem. Again, most popular award. It comes up a lot. Okay, number 5, it says 1 and 2 are complementary, and then 2 and 3 are complementary. Then 1 and 3 must be congruent. That was that congruent complements theorem. The next one, number 6, given 1 and 2 are right angles, therefore they are congruent. Well, all right angles are congruent. So if we're told that they're both right angles, they're congruent. Okay, then number 7 down here, 1 and 2 are supplementary. I see that. 2 and 3 are supplementary. So therefore, 1 is equal to 3. That would be congruent supplement theorem. And number 8, 1 is congruent to 2, 1 and 2 are supplementary, therefore 1 and 2 are right angles. And that would be if 2 angles are congruent and supplementary, then 2 right angles. And 2 right angles. Okay, next. Okay, over here. So now we're going to look at a couple proofs. There are actually 3 types of proofs that you may see. The one we've been focusing on is this 2-column proof, because as you're learning something new, I don't want to just keep throwing different formats because that's confusing. So we've been mostly focused on 2-column proofs, which is the primary format you'll see proofs in, is this 2-column proof. Another format is a paragraph proof, which we'll look at, and I'll show you it's the exact same as this right here. And then the third type of proof that you haven't seen yet, but I'm just going to show you kind of what it looks like, is a flow proof. And a flow proof looks like a flow chart, but it's literally the same setup as a proof. So it would start with the given, and then you go through like your steps and your reasons, and it looks like a flow chart, kind of like this. So you may see these throughout the year. I just want to let you know that sometimes you'll see a flow proof, but it's literally the same exact thing that we've been doing. Okay, so right here we're going to do the 2-column proof, and then we're going to take this information and put it into a paragraph proof just to introduce that format. And then this is the last page of the notes, which is cool. Okay, so given that angle 1 is congruent to angle 3, the first thing I would do on these, honestly, is plug in my given, because I can easily get that right. And then the proof statement, I'm going to put that in that last box, because that's where that's going to go, and I can get that right as well. Just like maximizing the points. Okay. So, from here, it says angle 3 is congruent to 6. So I'm looking at the picture, okay, 3 right here and 6 right here. Those are vertical angles. So the reason why 3 is congruent to 6 is vertical angle theorem. Then the next reason, it says transitive, so I'm looking at what I have here. Well, this is equal to 3 and this is equal to 3, so therefore 1 would equal 6. Angle 1 is congruent to angle 6 via transitive. Then it says 1 is congruent to 4. So I look at the picture again. Okay, 1 and 4 are vertical angles, and that's why they're equal, so vertical angle theorem. And then last but not least, it says 4 is congruent to 6. Well, in the last two steps, 4 and 6 were both equal to 1. So that means that 4 would be equal to 6. So they used transitive property. So literally the two that I told you were the most popular, vertical angle theorem and transitive property, come up a lot. Okay, so now we're going to take this and just put it into a proof and see that format. It is given that, so you'd put in your given statement, 1 is congruent to angle 3. We know that, next step says, we know that 3 is congruent to angle 6, since vertical angle theorem. So by the transitive property of congruence, we can say that, next step, angle 1 is congruent to angle 6. Then the fourth one, angle 1 is congruent to angle 4 by the vertical angle theorem. Therefore, we can conclude that angle 4 is congruent to angle 6 by the transitive property. Let's see. Okay, next. Okay, looking at this situation, before I even look at it though, I'm going to try to maximize my points and just put in given. Okay, so then from here, I'm looking at what the given actually says. It says KM bisects this angle. So by this being a bisector, that means this side of the angle is the same measure as this side. And that's literally what my next statement says. JKM is equal to MKL. That would be definition of angle bisector. Then it says that JKM, so this angle, plus MKL equals the whole thing. That was angle addition postulate. Angle addition postulate. Okay. And then they say, okay, MKL plus MKL equals JKL. So what they did here was, since JKM equals MKL, they plugged it in here for JKM. So that would be substitution. Then they combined like terms here to get this, so you could call that simplifying. Sometimes the book calls it substitution. And then to get to the last step, they divided both sides by 2. So it would be division property. Okay, last one of the whole packet. Okay, it says 1 and 4 form a linear pair. I see, given. So I'm just plugging that in. We're proving that angle 3 is congruent to angle 4. Right. So put that in the last spot. This sometimes happens. They have another given statement given here. They put the first one here, and then here I'll put the second part. Angle 1 and angle 2 are supplementary. Okay, so where are we going to go from here? So if 1 and 4 form a linear pair, that means they are supplementary, so we can say that 1 and angle 4 are supplementary. Then we have a given. Then it says congruent supplements theorem. If 1 and 4 are supplementary, 1 and 2 is supplementary, that means angle 2 and angle 4 are equal. Angle 2 is congruent to angle 4. Then they say this, angle 2 is congruent to angle 3. What I would do is look at the picture to see what their relationship is. They are vertical angles, so that is why they're equal. Vertical angle theorem. And then last but not least, 3 is equal to 4. Well, if angle 2 is equal to 4 and angle 2 is equal to 3, then 3 and 4 would be equal. And that is transitive. And that's it, folks. Okay. So that was the last of the packet. You can keep the packet while you do your homework if you'd like, or you can turn it in and I can try to grade it and get it back to you right quick. You have about 20 minutes to get your homework done, so grab a computer, get your homework done. If you finish your homework, work on Alex. Don't forget to turn in your notes. Appreciate it. Let me end the recording. Hold on. What's up, Kian?
Can you go to the one box?
Yeah, where's my mouse? It's hard to see. Okay, I got my... Oh, it's hard to see it. Okay, I'm trying to turn off the recording. There we go.